Hello listeners. In our previous video we have discussed about rational numbers and how you will find whether the number is terminating or non-terminating. Today we are going to discuss about irrational number. If you missed my previous video, go to the link given below this video or go to the Noble Education channel for all the videos. Subscribe and click on the bell icon for latest videos. Today we are going to discuss about irrational number. What is irrational number? A real number is called irrational number if it is not written in P by Q form. If it is written in P by Q form, we said that it is rational number. It cannot be written in the form of P by Q form. And take decimal expansion. Okay? Take decimal expansion of irrational number. If you are taking decimal expansion of irrational number, it must be in non-terminating and non-repeating. The number will be in non-terminating and non-repeating. Just take an example. Take any number 0.10111011110 so on. Okay, you can take any numbers. Okay, see that it is non-terminating and it is non-repeating, means here the numbers are not repeating in a series. What is the second? Means it cannot be in P by Q form. It cannot be in P by Q form. That is your irrational number, means it cannot be represented in P by Q form. Just take an example that what is a real number? We are discussing about real number. Real number, it is a combination of rational and irrational number, means it contains both rational number and irrational number. Just go for rational number. It is derived from the word ratio. It is derived from the word ratio, means rational number contain represented as ratio. Just go for irrational, means it cannot be represented in ratio. You can also locate irrational number in number line, and every real number can be represented in number line. So in this topic we are discussing how to prove irrationality of rational number. In this concept we prove irrationality of irrational number. Okay, what are the, just take example of irrational number: root 2, root 3, root 5, root 8, root 15, root 27, root 64. Some of the example of irrational numbers we have given. And the first question the student will ask you: any number which contains square root is a irrational number? That is your first question. Any square root number are irrational number? No. It is not necessary that any number which contain square root must be your irrational number. Just take your last 64. Okay, 64. If you are squaring 64, what you will get? 8 8s are 64. Square root cancel 8. 8 is your rational number. What we say that rational number is an integer. Rational number is integer. All integer number can be rational number, but there is not necessary that all rational numbers are integer. Means some of the beside integer there might be some numbers that contain rational factors. Okay, just go for next. Okay, we have discussed. And one more thing we can discuss, that positive integer. Okay, positive integer, square root of positive integer. You will get two results. Okay, and all positive integer must be your natural number, that you have discussed in your 9th class. Means square root of positive integer, you will get result as integer or irrational numbers. Two answer you will get it, whether integer number or irrational number. Means integer may be your rational number. It is not necessary that a rational number must be integer. Means it contain, beside integer also there might be some numbers that contains rational number, that represent your rational number. Okay, next go for square root of prime number. Okay, prime number. So 2 is your prime number, 3 is your prime number, 5 is your prime number. Okay, square root of prime number. Square root of prime number is compulsory, is your irrational number. This is 100% true. This is 100% true. But some number beside prime number also be a irrational number. Just take an example, root 15. 15 is not a prime number, but it is a irrational number. It is a irrational number. Square root of prime number is a compulsory irrational number. It's 100%. But some numbers which is not prime, but it contains square root, it will be a irrational number. Because 15 is not your prime. See here, 15 is not your prime. 8 is not your prime. But still it is a irrational number. So in this chapter we discuss we prove that the numbers are irrational number. Irrational number. There are certain numbers, just square root of 2, square root of summation root 2, 3 plus root 3, 2 root 2, root 2 by root 3. These numbers we have to prove irrational number by using fundamental, we have to prove by using fundamental theorem of arithmetic. Means with the help of this theorem we have to prove that these numbers are irrational numbers. So first of all we have to know what is fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Just take an example, 210. Okay. In our previous class we discussed how to find factors of a number. So what are the factors you will get of 210 is 2, 3, 5, 7. Okay. These are the factors you will get for 210. You can write in this order or you can write in this order. The order in which you want to write, you can write it. So every composite number, see composite means more than 2 numbers. If you are getting a factors, that will be considered as your composite number. Composite numbers can be expressed or factorized as a product of prime. As a product of prime means you are factorizing a number and you are getting a product of prime. See 2, 3, 5, 7, you got it as a product of prime. This factorization is unique. Whenever you are getting a factors, you are considering as unique, and the order in which you want to write, you can write it. And mostly we will write in ascending order, and we will get the factors of a product in ascending order. Okay, that is your fundamental theorem of arithmetic. Okay, in order to find out whether a number, we have to prove that whether that number is a irrational number. We have to prove the irrationality of that number. For that, you have to learn this theorem. We already discussed about fundamental theorem of arithmetic. Let P be a prime number. Let P be a prime number. You can consider that fundamental theorem of arithmetic. Means prime number means the factors you will get from a composite numbers. Okay, let P be a prime number and A be any positive integer. You can call positive integer as composite number. So just take A. Okay, what is your A? Be any positive number. Okay, means it is a product of prime number P1, P2 and P3. A is a product of prime number. Okay, if P divides A square, suppose you are squaring on both sides, A square equal to P1 square, P2 square, P3 square means squaring on both sides. Okay, squaring on both sides. So what we are saying, if P divides A square, if P is dividing your A square means it is dividing this also. Okay, if it is dividing this also means some number it is cancelling, some number it is cancelling, means let P divides A square. If P is dividing A square, then possibility that P also divides A. Let P divides A square. It means that P must be one of the prime factors P1, P2, P3. Means sum of the prime numbers will be cancelled. You can also say that P divides A. P divides A. Okay, in our next video, we will solve problem related to irrational number. Just subscribe my channel for latest updates.